All right, welcome to this video on multiplying numbers that are written in scientific notation. This will connect very much to what we did with multiplying exponential expressions because they have coefficients and then they have exponents. So as you will hopefully remember, when you are multiplying, you multiply the coefficients and then you add the exponent. So -2 times 7 is -14. And then a to the third times a to the sixth is a to the ninth. We add those exponents because they tell us how many of the a's we are multiplying. The only difference with scientific notation is that you can leave a negative exponent in the final answer. So here's an example where we are going to multiply two numbers that are written in scientific notation. We will multiply the coefficients. 2.3 times 2 will give us 4.6. Then we will multiplies the powers of 10 by adding the exponents. So 10 to the 6th, 10 to the -13th, we add those exponents and get 10 to the -7th. So that means our final answer for this product is 4.6 times 10 to the -7. Now, sometimes you will get, when multiplying, a number for the coefficient that is bigger than 10. And remember, we have to have our coefficient number be between 1 and 10. So if you do that, you'll just correct your scientific notation to get that number to be correct. So 4 times 5 right here is going to give us 20 times 10 to the, and then to get our power of 10, we add those exponents of -18 and -10 to get -28. Now we do need to correct this scientific notation. This needs to be between 1 and 10, so I move it to the left one, which means I add a power of 1 to my exponent. So my final answer is 2.0, or 2 times 10 to the -27 when I add those exponents. All right, let's look at the next one. If we do 8.2 times 7, we get 57.4. And then if I add my exponents, times 10 to the 47. But I need to correct my scientific notation because 57.4 is not between 1 and 10. So I make it 5.74. So I've subtracted a power, I add a power. No, oops, add a power. And that would be 48. So if it's not in proper scientific notation, we will correct it. And then also sometimes you will end up with one of the numbers or both not in scientific notation form. Usually it's just one of them. So we're going to take this 4,000 and we're going to put it in scientific notation first. Remember, we start with times 10 to the 0 and the decimals at the end. To make it be between 1 and 10, I would need to move 3 to the left. So I add 3 here, which means now we are doing 3.2 times 10 to the 7th times 4.0 times 10 to the 3rd, or just 4 times 10 to the 3rd. So I'm going to multiply my coefficient numbers of 3.2 and 4 and get 12.8. Add my exponents of 7 and 3 and get 10. This is now not in proper scientific notation, so I need to correct it, moving this to the left once because 1.28 is between 1 and 10, and then add a power of 10 onto the end to make sure that I make up for dividing by 10, and I get 1.28 times 10 to the 11th. Here are a couple of application problems that will use the idea of multiplying numbers in scientific notation. The first one is using distance equals rate times time. We have a speed of 5.2 times 10 to the 3rd kilometers per second. That's a rate. And we have a time of 4.5 times 10 to the 5th seconds. And it says how far. So the distance we do not know. So we will plug in what we know and solve for what we don't know. Distance is equal to the rate that they gave us times the time that they gave us. So I need to multiply that 5.2 times the 4.5, and I have 23.4 times 10 to the, my exponents of 3 and 5 make an exponent of 8. Then I'm going to correct my scientific notation because 23.4 is bigger than 10. So I'm moving 1 to the left and adding 1. So I have 2.34 times 10 to the ninth. And it says how far, that's a distance, and we are doing kilometers. Oops, wrong pen tool. So it's making everything perfect straight lines. So 2.34 times 10 to the ninth kilometers is the distance that would be traveled. The second and final example here is using that the area of a rectangle is the length times the width. A large rectangular plot of land has a certain length, because it says long, and a certain width. What is the area? So length is 3.2 times 10 to the fourth. Width is 1.8 times 10 to the third. Oops. 3.2 times 1.8 is 5.76. And then when I add my exponents, I get 7. And we keep in mind we're doing meters times meters, so that's going to be meters squared for our area. Okay, so that is the end of this lesson on multiplying numbers that are written in scientific notation. Join us for the next one where we will be doing dividing numbers in scientific notation.